Okay, guys, lesson 89, average value of a function and mean value theorem for integrals is what we are looking at today. This average value of a function, when you see the word find the average value of something within a calc problem, this is what we're going to want to go back to, okay, this average value of a function. So, definition of average value of a function. If f is continuous on the closed interval I, which is defined as from a to b, where b is larger than a, so top interval greater than the smaller interval, then the average value of f is given by, and you'll notice it's basically the integral of f of x dx from a to b, but what's out in front? 1 over b minus a. Okay, so, and that's just in order to find the average value, you're taking the value, that integral value there, and dividing by b minus a, which is the width of the interval. Okay, so this is the average value definition, and what we're going to be using. So as we look at example 1, notice what it says right off the bat. Find the average value, so that means we're going to be using this guy right there. Find the average value of the function, f of x equals x squared minus 10 on the interval I, which is defined as negative 1 to 2. Okay. Let me ask, what are a and b?
B is 2, A is B.
Yes? Yeah. Okay. So because it's in the order A, comma B, and it's also defined where B has to be larger than A. So let's fill it in.
What happens if there's we're thinking where B is not?
We wouldn't be talking average value here. I mean, it just, we would, I don't know, things would have to change. So here,
See a problem like that?
right, yeah, the ones you'll be given, the B will be a bit larger than the A. Okay, so average value says to start off doing what? 1 over B minus A. So that means we're doing 1 over,
2 plus 1.
okay. I heard 1 over 3. I heard 1 over 2 plus 1. I wrote 1 over 2 minus negative 1. We're all in the same boat there, right? The integral from negative 1 to 2 of f of x dx. So what is my function here? X squared minus 10 dx. Here it's doing the math. We're going to do this by hand, so this is definitely good practice. First of all, if you didn't already clean that up out front, this is 1/3 times, okay, integral of x squared.
X to the third over 3.
Yeah, 1/3 x cubed.
Okay, so integral, we're going up in powers, add 1 to the power, divide by a new power. So whichever way you put it, 1/3 x cubed or x cubed over 3 minus integral of 10
10x.
and x. Evaluated from negative 1 to 2. So this 1/3 out front, my recommendation is keep it out front.
So at this point, are we just plugging it in?
Yeah, and so at this point it is typical, officially it's called fundamental theorem of calculus when you're evaluating this integral. So we start by plugging in the,
Negative 1.
nope,
No, 2.
the 2, the top interval. So 1/3 times 2 to the third. 2 to the third is 8 divided by 3, so 8/3 minus 10 times 2 is 20. I'm going to end that parenthesis and then plus or minus? Minus. And now we're going to plug in our bottom boundary. So plug in negative 1. 1/3 times negative 1 cubed, negative 1/3, minus 10 times negative 1 becomes plus 10. Okay. Clean it up however you want, preferably without using the calculator though. Make our brains work. You know.
52 thirds.
Oh, here we go. Are you guys okay if I go out of order? Look at the pieces here. 8/3. There you go. Yep. Okay, so you guys see it? 8/3 minus negative 1/3. So that's going to be 8/3 plus 1/3, which is, no, minus negative. So 8/3 plus 1/3, 9/3, which is 3. So those two make a 3. Negative 20 minus 10. So negative 20 minus 10 is negative 30, plus the 3 I just had, negative 27. And then officially we had that 1/3 out there. So 1/3 times negative 27, which is negative 9. That's it. I mean, it's really doing the integral, which we already know how to do, and just doing that fraction out in front of it. Now, this is average value, and we got a negative. Okay? No, it does not. All I just want to talk about is that if you have a negative average value, that just indicates that your average value is where in relation to the x-axis? Below. A positive average value would indicate that it would be above. So just kind of a side note there. That the negative, am I on the screen? I am. Indicates average value is below the x-axis. Let me finish writing. Negative indicates average value is below the x-axis.
Hi, Cassidy.
Now we'll know she really watched the lesson.
Unless you tell her you said hi to her.
Well, we'll wait.
You wait and see.
Tell her the day after. It's gotta be a surprise.
Okay. Okay, example 2. Let's go with it. Approximate the average value of the function f of x equals 4e to the 2x on the interval 0 to 3. Okay. What are a and b?
B is 3 and A is 0.
Okay. B is 3, a is 0 based on the interval a to b.
Just be 1/3.
So 1/3. Notice it does say approximate the average value. So it says average value, so we're using the integral with that fraction out front, and approximate. That'll matter at the end. So as we set this up, I'm officially going to write 1/3 minus 0. Integral from 0 to 3 of 4e to the 2x dx. Okay, let's go ahead and work this. 1/3 minus 0 is 1/3. I personally would think about this 4 as just being a separate number, because that's a constant that could officially be pulled out front, right? And so the part that I need you to think about is that right there. What is the integral of e to the 2x? Right. 1/2 e to the 2x, because derivative or integral of e to some power is e to some power, right? Now, if we're integrating, we have to compensate for the chain rule. Because normally the chain rule would say then times the derivative of 2x, which is 2. So this is integrating, so we have to compensate, and we're going to say 1/2 e to the 2x. And so that right there is my integral piece. evaluated from 0 to 3. So if I do 1/3 times 4 times 1/2, if I multiply those all together right now, 4/6, which reduces to 2/3. And then we're only worrying about e to the 2x at that point. So it's e to the 2 times 3, e to the 6th, minus what?
It's 2/3.
Well, I've already got my 2/3 factored out front. Sorry. So I've got all of these pieces factored right there into 2/3. Okay, so if I'm plugging in here 3, e to the 6th minus, officially if we plug in 0, you could say e to the 0. However, go one more step and know that e to the 0 is 1. So if you want an exact answer, 2/3 times e to the 6th minus 1. If they say approximate, then you can do a decimal answer here. Okay, now, the decimal answer, we can plug this in right here and get a decimal answer. It would also be the same as plugging this original integral in, and it should work out the same. You want me to tell you? You guys going to do it? I guess Carly's on the way to doing it, isn't she?
Don't say it already. 268.2859.
So I have written down 268.2859. Okay. So when you see that word, find the average value. You know what formula you got to use tonight, right? I'm trying. Okay. Excuse me. Mean value theorem for integrals. It reads, if f is continuous on the interval from a to b, there exists at least one number c between a and b such that f of c equals 1 over b minus a times the integral from a to b of f of x dx. Okay, so what is this saying here? If f is continuous on this interval, there's at least one number c that's in the interval that when I plug that value in, we're going to get f of c. We're going to get that average value. Okay, so there in that interval, your average value is just an average of all the values, right? So this is just saying that that average value will actually exist at least one point because it's also a continuous function. Okay, this is one of those existence theorems is what they'll call them. Okay. So, my example here says that given the average value of f of x equals 2x cubed, so notice again it used the word average value, on the interval 0 to 3 is 27 halves. So what did they just say? Given the average value of f of x on this interval, and they said what? Is 27 halves. So what is this 27 halves? It is the same, the average value, the thing we've been solving for. Okay, so they're saying that right there is 27 halves. It is the average value.
So what am I supposed to do?
Okay, hold on.
So you're supposed to find c.
Okay, so then the question says, use the mean value theorem for integrals to find some number c such that f of c equals 27 halves. So we're trying to find a value c where they're going to equal each other.
So do we do just the exact same thing if we end up getting 27 halves of right?
No, because we're trying to find C.
We need to work it backwards.
Well,
We need to find X.
kind of, except we're going to call it C. Okay, so our function is defined as f of x equals 2x cubed, yes? So if f of x is 2x cubed, what is f of c? 2c cubed. Make sense? Now, up here,
Wouldn't it be
f of c is defined to be this right here. This is a lot easier than what you think it's going to be. Okay? So f of c is to be defined as the average value. F of c equals what? 27 halves. So we know f of c, when I plug c into my original function, is 2c cubed. We are also told that f of c equals 27 halves. What's the equation I can set up here? Set them equal to each other.
Neither was that.
2c cubed equals 27 halves. How do I solve for c? Okay, divide by 2, take the cube root. When I divide by 2, that's also multiplying by 1/2. So this becomes 27/4, if you will. The cube root, when we take the cube root, c is the cube root of 27/4. I can do the cube root of 27. Can't do the cube root of the 4, though. And I have a decimal answer, which means I put this in my calculator. What is the cube root of 27/4? Gonna make you think about how to use your calculator here.
Math menu.
Oh,
It's in the math menu.
1.8890. It's 3 and then 1.8899.
I say I have 1.8899.
I think it's highly unfair that Jeff uses his calculator significantly quicker than I do, so he always has the answer before I do.
You just explore it.
Anyways.
No, you just click the buttons faster.
Okay, guys. So, average value. Here's the key. Here's the deal, guys. You see that word, find the average value. From this day forward, you find the average. That's kind of a key word there. You've got to remember, okay, we're going to do the integral. We have to put that 1 over b minus a in front of it. Okay, there's 2 assignment changes here, and I'm going to give you 2 more. So, problem 1 needs to be changed to number 7 from 77. Problem 3 needs to be changed to number 23 from 86. And 14 and 16 need to be changed to 20 and 21 from 87. Yes.